Since none of you have been here before, we're going to do a couple of things. First is normally our everything that we do for an assignment, the solutions are online. The solutions for what we did is online because I pulled them from last year's curriculum. That just means they're in the Glencoe folder. Okay, so if you didn't see them, that's okay. Here they are. There's our stuff. What else was I going to do? I was going to poke the button. So if you want to go through and check those quick, I know some of us, I want the solutions to all be online. Okay, if we need to go through these, we can go through these. 2 is at the beginning of every class, when you come in, I'm going to have the daily check up here and you're going to just sit down and get to work right away. Okay, that way, as I'm doing attendance and getting crap ready, you are active, you are doing something, you're getting back in math mode. You're going to do 1 to 2 level or 1 to 2 problems, C level, middle of the road. And you do that wherever you want to. Now, your assignments and your daily check, if you want to do them in a separate notebook, fine. If you want to do them in the back of that packet, there's X amount of blank pages back there every time. And it's set up in such a way that if you don't write gigantinormous, you should be able to put your assignment and your daily check on a page. Assignment and daily check on a page, because our assignments are going to be fairly small. This is more numbers than I would normally assign because it was just a lot of scattered things. This happens a lot in chapter 0. After that, we tone it down. It's more like do these 4. Okay? So if you want to do them in the back of the packet, then all you have to keep track of for this class is where's my book? I have my packet. You're good. Okay? If you want to put it in a notebook instead, just make sure that everything is labeled. I need to be able to find it. If you make it harder for me to decipher your stuff, then I procrastinate and I sit on your notebook over there for 2 months. I'm just going to admit it. Okay? Y'all know we don't do the thing that we don't want to do. You shy away from it. How many of you do your homework for any class at like 11 p.m. Sunday night? Okay? You know who you are. So, we'll come back to this. In the meantime, not you. That's the auto-saved version. I said not you. I said not you! Go away. There we go. There you go. Whether you're going to do it in your notebook or in the back of your packet, you label 0-1 sets, 0-2 complex numbers, and you do these 2 problems. That's it. I know that I need to upgrade the font size on those, and they're all individual text boxes. Is there anyone who can't tell what's what over there? Or are we good on the Venn diagram? We can tell what numbers go where?
Yeah.
Okay. That's it. Do this and this. And then I go through it and I tell you how to score it. So every day you're going to come in, do 1 to 2 middle of the road C level problems, and I tell you how to score it. And this is our formative assessment. Remember, when we are working on stuff in class, I want you working together. This is your gut check. This is how you determine, do I understand yesterday or not? So for this, you do you. Okay? There's no use looking over at your neighbor's stuff or asking your neighbor something, realizing you missed a negative, changing that, and now I got my 5 out of 5. You're like, great. Now you have a full sense of security about what you can do. Okay? When you finish, by all means, if you want to converse or compare answers with your neighbor, great. Just don't change anything. Okay? This is you evaluating your knowledge. Do you understand? Most days you're going to be getting 4 or 5 out of 5. But if you're ever getting a 3 out of 5 or a 2 out of 5, that means you need to ask questions. Okay? Stay after class. Hang out for a little bit in Spartan time. Go through a couple of examples like that, and you'll be fine. Okay? It should be relatively quick. It's rare that these take us more than 5-10 minutes. Everyone's at least on to the second one, so I can put the answers back up there for the other thing. Just for anyone who needs to check them. Tell you what, if you got 9 100% on your own, you're going to do just fine in this class. Oh, yeah. Remember, especially in a small group like this, it's going to be super important that you speak up if you got questions, if you need me to change something. You got a class of 25, it's really easy for someone else to ask the thing for you. But in a group of 10, the chances are you need to ask. Yes, ma'am.
Can you explain how you got this answer?
For this guy?
Yeah.
Okay. Because when I multiply exponents at the same base, you add.
Oh.
So that's 8.
Oh, that makes sense.
And that's 33.
Okay.
Good? Okay, anyone need more time? Got there? Okay. Okay, first up. What's that say? Close. Union, which means or, right? It's kind of like, what is this? It's a thumb. No, it's a phalange. Get it right. Like, yes. Okay. It's the or of the math world, but it says union. What is this? Not B, but what's the big kid word? Well, I don't know that word. Complement of. Okay. No, I don't speak Honduran. So we're going to have A union, not B. So A is all this stuff. Union Green? Not B is everything that's outside of B. So that's all this, including that 6 that was hiding outside there. Now we got to be super careful here. If it says A intersect, not B, then it would only be 2 and 8, right? Because that's in A and it's outside of B. But because it says or is the least restrictive thing you can do. Like, and is restrictive, or is inclusive. Or means anything that I just shaded is fair game. So all of that counts, even the 5 and the 1, because they are still a part of my shaded regions. Anything that I just shaded works. So my solution is 1, 2, 5, 6, 7, 8.
That makes no sense.
Or.
Because it's like what's in A but not B. No, that's when it's what's in A and B but not B. I don't know. It doesn't.
You're thinking and. If it's in A and isn't in B, then I would look at A stuff, but I would only choose the stuff that isn't in B. Because I said or, everyone, I'm going to give you very specific directions. Ready? I want you to stand up or sit down. Good job. As long as you met one of the conditions, it's correct.
About C.
But isn't this not B? It's outside of B.
Yeah, but it didn't say anything about C.
Okay, think of it this. Let's do them separate then. Name everything that isn't in B. 2, 8, 6, 7. Right? Name everything that is in A. 1. Anything I just said is in one or the other.
Yeah, but then it's asking what's in A. So, but 5 and 1 are in B. So then they wouldn't. I don't know.
That's what a union is. A union means everything that I just said is a part of my answer. All of it. I said 1, I said 2, I said 5, I said 6, I said 7, I said 8. If I said it twice, it doesn't matter. I'm not going to say it twice. Literally everything that I just said. If this is an and, then I have to look for only the things that were both. That would be just these. I don't have to meet both conditions to be included in this answer. I have to meet this condition or that condition. If those two have a little bit of overlap, that's okay. It's kind of like if I was going to say in here, list out every student who is wearing jeans. List out every student who does not have glasses. And now I say, which students are wearing jeans or don't have glasses? I wouldn't exclude the kids who are only doing one or the other. I wouldn't exclude the kids who are doing both. As long as you meet one of the two conditions, it's right. It is part of the answer.
So if you're in A and not in B, that's
Still good.
That's the two conditions. That's what two.
If I'm in A, it's good. If it's not B, it's good. If it's in A and not B, it's just double good. Or means everything that was just listed qualifies.
I don't know why it doesn't make sense. Because or is like everything that's, like, if you say A or B, it's everything that's in both of them, right?
No. In A or B.
Yeah. So everything
All
that's in
together.
A or B. So that'd be like 3, 4, 5, 1, 2, 8, right?
What?
Yes.
That's A or B.
Yes.
So then,
But it says no.
so what's, so 5 and 1 are in B, so it's like they're not, no, just doesn't make sense. Like,
We're goofing the double negative here.
I'm just
The
trying to
or,
explain why it makes sense to me. So,
Okay.
the or like overpowers the not.
yeah.
Yeah.
Or is the most inclusive you can be.
Okay. I guess.
Or is more powerful than not. There.
Didn't have that picture, and it was just you have the universal set,
Mm-hmm.
all those numbers,
Mm-hmm.
and so how would you know to include the C or whatever?
You, just like this, you list out everything that's A,
So you would
list out everything that's not B,
Oh.
and if I just wrote a number, it's on the list.
Okay, it makes sense. So everything that's A and everything that's not B. So everything that's A or not B.
Yeah.
Okay.
I don't know what I just said different, but it clicked and I'm happy.
Yeah. Okay. Yeah.
I don't understand what you said, Max, but
But it worked.
Yeah,
No,
now it makes sense.
yo, this is what I mean though, is the little bit of clarification. Whatever that just was, that was the cartoon light bulb, right? It just clicked, like the wires just crossed. There goes the trash. Like you have completed your task. It's good. Okay. I don't know what I said differently, but it works and I'm happy.
Yeah.
I want you to get that clarification. Okay? Kids often get this, you almost get chastised and punished for asking questions, right? Or you feel like this should not be difficult. I'm just going to stop talking. No, push through. We need to make it work. Okay? Good on you. Second one. What do I multiply by?
-2 plus I.
Okay. Well, is it -2 plus I or is it +2 plus I?
Negative 2 plus I.
It does matter. It has to be the same thing with the sign in the middle changed. It is still -2. Yes. No, I'm just confirming that we know what the conjugate is. You change a sign in the middle, never change the first one. Okay? So now that's -2 plus I, -2 plus I, and we distribute. Watch your signs. 5 by -2, -10. 5 by I, 5 i's. 3i by -2, -6 i's. 3i by I, 3i squared. -2 by -2, 4. -2 by I, -2i. Negative I by -2, +2i. Negative I by -I is minus I squared. And don't you dare start this. Thank you. I squared is really a -1, so this is -3. I squared is really a -1, so this is +1. Combine like terms. I have a -10 minus 3 is a -13. 5 i's minus 6 i's is minus 1 i's. -2i and 2i cancel town. 4 plus 1 is 5. Now, I'm okay if you left it like that, because all it said was simplify. If the directions specifically state write it as a complex number, you have to separate your real friends from your imaginary friends. And you would write it as a plus bi separated. Okay? So either one of those is cool. Remember that 1 times I over 1 would be I on the numerator. So I can separate it like that.
If we put the I up by the 1, would that be wrong?
No, you're cool. Same thing. Now, if you said 1i on the numerator, now we haven't simplified because you don't need the coefficient of 1. It's day 1. I'm cool with it. Okay?
Okay, so for the first one, if it's A and not B, so that means it has to be in A.
And it can't be in B. That would just be 8 and 2.
So I was just flip-flopping and or over, kinda.
And we've come full circle when I said if it was and, yes.
Yeah.
All right, we're there. So every time we do this, it's going to be out of, where we go? All right. It's going to be something out of 5. You're going to box it, circle it, label it, highlight it, something. And I'll just tell you ballpark what the points are. Sometimes it's this amount of points for these things. Sometimes it's a point for a very specific criteria. Sometimes it's a Likert scale where it's like 5, I'm awesome, 0, I didn't even try, and then in between, right? This, I'm going to say 2 for our sets. Turn your phones off before you come to class. Wait. That's on Do Not Disturb. Why is it going through? Oh, I updated my settings. Stop it! That's my wife. And if I got that many pictures, either someone's dead or if I got that many messages, someone's either dead or she's sending pictures. And 3 for this guy. Basically here, I'm betting most of us had the 2876 part. It's whether or not we had the 5-1 is where most kids goof on that. Okay, so 2 points for this. 2, you got all of the stuff the way it was supposed to. 1 would be I missed part of it or I misunderstood what this part was, but I got most of it. Here, something out of 3, meaning did you distribute numerator and denominator correctly? Did you simplify numerator and denominator correctly? Did you get your signs right? Did you accidentally miss a negative back here? Like there's all these little things that could have gone wrong, right? You're going to find out real quick in here, I am obsessed with I will give you credit for what you did right. If you do this one thing wrong back here, that domino affects everything else, I'm still only saying 1 off. Okay, the domino effect should not destroy your entire grade. You all know when you've done like an entire page of work and it turns out you missed a negative on line 1, or you wrote down a 3 instead of an 8, or you can't read your own handwriting. Like, if that happens, can you do all the right stuff based off of incorrect information? Can you make all the right decisions based off of something that was false? I'm looking at all of this if I see that and still giving you 1 off, everything else cool. Okay? So when I say something out of 5, yeah, there's a bunch of places you went wrong over here. If you screwed up like 2, 3 different things, okay, now we're taking multiple points off. Okay?
So, like, now that I get the first one, do I still take a point off, or?
Well, yeah, that was a misconception. This is how we.
I didn't know if it was like
Yep.
you're scoring how you understand it.
It was a misconception that now we understand, oh, wait, this is something I need to work on. And you can just Google, like, just set problems or Venn diagram problems and just try stuff. Go to Khan Academy. You can just wander down here during Spartan time and I'll throw a couple of random things on a board and say, have at it. Okay? So, bonk. No. There. Were there any of these that were iffy on us besides 9? I'm pretty sure 9 was iffy. 10? Put your real friends with your real friends and your imaginary friends with your imaginary
I was
friends.
confused by the 3IY, like what you have a Y in it.
Well, if I say negative 5x plus 3iy is, what's that, 10 minus 9i, you match real friend with real friend. divide. Right? Because the real and imaginary parts can't mix and mingle. The real thing has to equal the real thing. Just like the imaginary thing has to equal the imaginary thing. And multiplication is commutative, so this is also 3yi, right? It's also y3i. It's just you start getting cross-eyed if you write it like that. The reason it was written this way is because now look at what happens when I just divide both sides by 3i. -3.
Does it cross out?
Yep, i's cancel down. 3-1. This is a really good example of something we're going to do later in the course that's called partial fractions. Partial fractions lead into calculus and finding derivatives, where you need to break things up and say, this goes with that, this goes with that, this goes with that. It's just like sorting Legos. Okay?
For 9, how do you do a square root of -2i times square root of -6i?
And that's why I include this one every year, is because when you are solving by complete the square quadratic formula, I bet most of the time you wrote your answers as something like this. Right? It's technically incorrect, because I should always go at the end because I'm working with it kind of like a variable, right? I don't say x3. I say 3x. This should be written as 3/5 plus or minus. Do I say 2 root of 3/5 over 5i? Like it's a coefficient of I, right? The problem with that is if I say the square root of 3i, the square root of 3i, the square root of 3i, square root of 3i, which of those was the I under the radical? And which of those is it square root of 3 as a coefficient of I?
Can't tell.
Unless you're super neat with your handwriting, it's very difficult to tell.
Was that I outside the radical?
Well,
Yeah. Oh.
it's a coefficient of I.
So you basically do nothing to the problem.
You don't do anything.
I'm not allowed to have a radical downstairs. I'm not allowed to have an I downstairs. I still have to rationalize it. It's just, you were probably used to seeing this as 2 minus I root of 2, like that.
Yeah.
But that's actually the improper way to write it. Now, this is the formal fancy pants. I'm wearing like James Bond tux, you know, the knot in the tie is perfectly geometric, shine your shoes kind of way to write it. I got no problem with jeans and work boots. Okay? This is how we can work. But when we get to the end for our answer, I will take either one of these. In a few years, you might be in some crotchety math professor's class. You might be typing things in on an online like D2L or Blackboard, and you have to do it their way or else. I know at some point in your mathematical career, you've probably done Math Excel. How many times did you get it wrong because you didn't type it the way that it was supposed to be? Right? That's why I bring stuff like this up. Now, if we want to 2 root of 2, 3 root of 6. That was a minus, wasn't it?
Yeah.
Okay. So you still use your conjugates. This is in A plus BI form. That's another reason we write it like this. I multiply by 3 minus root of 6, I, 3 minus root of 6, I. And when I disturb it, it's going to be butt ugly. You got to remember, 2 by 3 is regular town. 2 by negative root of 6I is minus 2 root of 6 i's. What's outside of radical land stays outside of radical land. What's inside goes inside. Negative root of 2I times 3 is minus... No, I wrote that backwards first hour this morning too. I still got to put their brownie points up there. Y'all, get on the board. First blood. Let's go. Negative 3 root of 2 i's. And then this times this. Well, these are both inside of radical land, 2 and 6. So plus root of 2 by 6 is 12 I squared. Outside radical with outside radical. Inside radical with inside radical. If they share the same index. They're both square roots, so I can get away with this. If that was square root times cube root, now I have to go to rational exponents instead and hope that the bases are the same. Okay. Everything down here, 3 by 3. 3 by radical. Minus 3 root of 6 i's plus 3 root of 6 i's. Root of 6 by root of 6 is 6 I squared. I hope that you have been simplifying radicals in your classes for the last 2 years straight. 3. If they have been letting you get away with calling this 3-point something in any of your classes, they have done you a huge disservice because we know how to simplify radicals. What is that? 2 root of 3. Okay. If you got to go separate as 4 by 3, square root of 4 is 2. Or if you got to go really old school and break up 12 by factor tree, circle a pair, they rush the guard, one gets out alive. Y'all remember that? Okay, or something like it. Depends on your teacher and their analogy. Mine is always there's a level 2 guard in the doorway, so it takes 2 guys to rush him. But he's a tough guard, so only one makes it out. This is I squared, so it's really a negative. This isn't root of 12, this is negative 2 root of 3. This is a negative 1, turns it into positive 6. Separate your real friends from your imaginary friends. Oh, and then all this is gone. 6 is real. Negative 2 root of 3 is real. Real stuff goes together. Imaginary stuff goes together. These are called compound numbers. You worked with them in Algebra 1 and 2, hopefully in geometry. A compound number is a number that involves both rational and irrational components, and it can't be simplified any further than this. You just have to have them stand awkwardly next to each other. It's like if I said 4x plus 2a. You just leave it as 4x over plus 2a, and it just has to stay that way. Now, since all of this was over 9 plus 6 is 15. Since they're both over 15, it's the same as this is over 15 and this is over 15. Well, since those are over 15, that means every single individual one of these is also over 15. So I can reduce that way. What we don't want to do is kill a mathematical puppy and try to do this. If you do that, oh, that's freshman math right there. Remember, it's like multiplication and division within mathematics. It's like we always say math is communist. What you do for one, you do for all. If I do it here and here, I better do it here because they're all lumped together. They're all in the same colony, right? So when you separate these, be careful that this has to be 6 over 15 is 2 over 5 minus 2 root of 3 over 15 is the real portion. Over here, this over 15 doesn't change. Negative 2 root of 6 over 15. This over this, okay, I can reduce that. Now that's minus root of 2 over 5 i's. You learned all the tools to do exactly this in Algebra 2. I bet you never had to crank it up to an 11 like this. But do you see all the individual skills? Like, I know how to do that. 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 Well, how many of you are in sports? Like, I know how to run. I know how to, well, I used to know how to run. I know how to run. I know how to jump. I know how to hop on one foot. But y'all, it has been 22 years since I've done triple jump. I'll break my ankle if I try that now, because when I try to put it all together at once, that ain't working. Okay? There are so many individual skills here. This is a prime example of how Algebra 2 leads into PreCalc. Why PreCalc is past college algebra. Because we assume that if you did it, you know how to do it. And now we're just going to start throwing everything together chef salad style. Okay? So, a couple of things that I don't remember if I said yesterday and in which class. Remember, if you go into the Google Drive folder and then into the old Glencoe stuff, I do have the notes for the whole class, like section by section, chapter by chapter. Think of the stuff that we just did yesterday. Look at what we got. Set notation, my ring, what conjugates are. Take a look at what we're doing today. How to do parabolas, how to write my vertex form, how to write my general versus standard form, what a stretch or compression is, even your old vertical motion model from Algebra 1. It's all right there. So if that's something that you would like on hand, it's available. You just print it out at your leisure. There's also, I can send out if you need, the Algebra 2 version, which is just, hey, you should know all this stuff. Okay? 03, here we go. In Algebra 1, you learned what a quadratic was, and you spent about a month on working with quadratics. In Algebra 2, you probably spent another month working on quadratics because they're just that important. We tossed in imaginary numbers, and then we went to polynomials. Just like in geometry, you know how you spend like a month and a half on triangles? You spend all that time on triangles because after that, what about quadrilaterals? Right? You just throw a diagonal on there and it's two triangles. If I go to a pentagon, if I go to a duodecagon, I can just keep chopping it up and it's a bunch of triangles. If everything is triangles, then I should just know triangles really well. And then everything else follows. I spend so much time on quadratics in Algebra 1 and 2 because once you got to polynomials, didn't you keep breaking x to the fifth down to a bunch of linear and quadratic factors? If I know lines and quadratics, I'm good to go. So what is the graph of a quadratic called? Parabola. That parabola comes from one of two forms. You either have this is called the general form. You may have heard it called the standard form before. That is incorrect. We'll often call the standard form in Algebra 2 and lower because this guy Sometimes it's called transformation or vertex form. Other times they call it, well, they'll call it vertex form in lower textbooks, but in the upper textbooks, this is actually standard form. You hold on to that thought until chapter 7, because it turns out there's a crap ton of stuff about parabolas we never told you. By definition, the parabola is a locus of all points such that they are equidistant, a point between the focus and the point back to the directrix. You're like, focus and directrix. What? Yeah, there's other features in there. Or, we don't use it as much in this class, the latus rectum. Okay? That's just funny to say, latus rectum. It's literally called that because it's the width of the opening. Okay? So there's all of this stuff about parabolas we didn't know yet. Parabolas are a type of conic section. Parabolas, ellipses, circles, hyperbolas, or hyperbolae if you want to be correct, they all have their own standard form that tells you where to find their vertex or covertices or center. But they all share general form, which is throw everything in descending order. That's called general form. Okay? With these, what's that guy called? Vertex. A vertex specifically is where my function goes from increasing to decreasing, or vice versa. See, it's decreasing, 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 decreasing. It's the turning point where now I'm increasing. Okay, what's this guy? Yint. Okay, my y-intercept. The x-intercepts are also called zeros, are also called roots, are also called solutions. This would just be a symmetric point. A symmetric point because what's a blue line? Okay, specifically an axis of symmetry. It depends on which textbook you're in. The axis of symmetry is an invisible line that splits your parabola in half. And it's really nice because if I got a point on this side, say I go 4 to the right, then I'll also go 4 to the left. Symmetric, just like butterfly. Those vertices can be either, what are other words for them, depending whether they're the lowest or highest on there?
Like the maximum.
There you go. We've got the minimum and the maximum. A parabola is going to have a minimum or a maximum dependent on whether I have an A coefficient that is positive or negative. If you look up around the room, these are basically set up for pre-calc. Right there, you got the happy parabola and the sad parabola. Fifth in from the left. If it's positive, it's happy. If it's negative, it's sad. Okay? Now, we should have graphed the bejesus out of these things for the last few years. 2, negative 8, 4. Plus 4. Okay. Notice this says graph by table. Way number 1, old school, right? That's old school, where you would pick x's, dependent on whatever criteria, plug them in, get the y's that go with them. Homie, don't play that. In Algebra 2, you should have stopped doing this. Because, where's the table?
On your calculator.
Y'all, work smarter, not harder. Everyone get a graphing calculator in front of you.
Second white or no, second graph. Hey buddy,
Look how slim these are.
Come on, Frank.
Hello?
Okay, before we can do anything else, depending which calculator you just picked up, it might have a little bit of parabola stuff in there from this morning. It might have God knows what from the pre-calc final. So we need to reset them so everyone's starting fresh. Cookie. Do not stab it in the back. Okay? When you stab it in the back with a pencil, over time, especially if that calculator is used incessantly in a class, the graphite builds up around it and it can gunk up the circuit board itself, or it can hold the reset button down so that it just won't turn back on. Then I have to pry them open. You'll notice some of the yellow bumblebees, they got a bunch of like scratch and claw marks on the side of them. That's for me prying those open with a screwdriver. Okay? Having to clean them out because kids weren't listening. We're going to reset them the correct way. Anyone know the mantra? Get used to it because boy, are you going to have that memorized. Second plus 7, enter 2. Because second, right above plus, what does it say? Memory. Option number 7 resets the calculator.
Wow. Second.
I enter on all RAM. Now, be careful. If you have your own personal calculator, be careful. If you do reset all RAM and you have anything programmed in there, you will lose it. Legit. The TI-83s, those, I was using those in high school. And we programmed Monopoly, Wheel of Fortune, and Zelda Link's Awakening on there. No joke, dude. Oh, yeah. It took forever to code that on there. But if you do all RAM, it will delete everything. So be careful if you have anything programmed in, or if you downloaded any apps onto yours. There's really cool like math apps that are on here, depending on when it was purchased or yeah. All RAM 2 is because yes, like they're gonna ask you, buddy, you're about to lose Pac-Man. Are you sure? Yes. Okay. So second plus 7 enter 2 is how we're gonna reset them. Give me the your Algebra 2 graphing calculator experience. I am a pro. I can make a line, and I know where the table is. How do I make a fraction?
Oh, I don't know how to.
Where are we at? Where are we at? Oof. Okay, y'all gonna be pros when you come out of here. I probably same thing. Does it plus? It's a plus, right? Okay, yeah. So you still got the alpha shortcuts. You're good. If you don't have the alpha shortcuts, some of the stuff we do in here might be a little bit different. Okay, alpha, and this whole top row brings up. Oof. Alpha and this whole top row brings up shortcuts. Like if I go to alpha graph, nothing, right? It just does normal graph. If I do alpha trace though, now I'm talking about where I want to store my functions. I hope you all did regression algorithms. Like find the quadratic model for this, store it into your calculator. Oh.
I was probably gone that day.
Oof. Okay. Notice there's also function. So alpha right above function is window. Mine's offset because of the emulator. These are going to be the most commonly used functions in your calculator, so they have a shortcut for them.
Oh, it's the like.
Okay. Alpha right above y equals is fraction. I can do a regular improper fraction, I can do a mixed number, I can swap between the two, and I can swap between fraction and decimal. What it won't do is simplify radicals for you. Okay? Alpha y equals brings up box over box. So, how do I enter my function? It was 2x squared something 8x4. Y equals. Regular y equals. No, stop it.
2x.
So we type in, be careful if you use the caret to go up into exponent land, you have to arrow over to say you're done in exponent land. Otherwise, if I say 2x arrow up to minus 8x, look at where it's typing. Okay?
We learned that.
So you have to arrow over to say you're done with it, and then minus 8x plus 4. Okay. I have typed thing. What you do not do in this room, don't you dare, is you hit graph. And you see that. So you do that and move on with your day. If you do that, you, me, skate park, after school, like, stop it. Okay? We're going to do this for real. They said graph by table, so I'm going to go find a table. Where's a table?
Under second graph.
Okay, second, right above graph is table. Now, your table will automatically default to starting at 0 and going by integers. If I just scroll up a little bit, I see some more points. I can now go put some points. All right, so I see 2, 4. I see 2, 1, 2, 3, 1, 2, 3, poke. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, poke. Poke, poke, poke. Okay, plot points.
46.
You do not have to copy the table. If you ever graph something by table, or if you ever have to use a table for any feature in this class, you will not copy it down, because that is lame. All right? You see the table right there. You can replicate it if you need to. So just plot the points and you're good to go. When you connect the dots, y'all, this is a parabola, not an absolute value. Please make sure we want to keep it curvy. Okay, don't make a point, don't make a V. Mine's really bad because I tried to make a 3-foot tall parabola and I just can't keep my hands straight that long. Yo, when you make a parabola, try to keep it curvy, not like that, because this is absolute value, this is parabola x squared. Okay, Beyonce, not Amanda Seyfried. Right? She's a stick.
Okay.
Eat something, girl. Okay. Now, I said that it defaults to starting at 0 and going by integers if you look above window, table settings. You can tell your table where to start. You can tell it to go by 100ths. You can tell it to go by 30s. You can change your independent. I hope this sounds familiar. Change your independent over to ask so that you put in whatever x you are feeling like and it'll just tell you the answer. Okay?
Dude, she didn't teach
She didn't
stuff.
I promise.
Yeah, I promise.
Oof. Okay. I said, you're going to get good. Like, kids who come out of PreCalc are usually really good with TI-84s. I use them a lot because we are really, really heavy on function analysis in here. Oddly enough, you would think independent over to ask, I'm going to put in the x, it tells me y. You would think that putting dependent over to ask, I should be able to put in y and it gives me x, right? It doesn't. I have never found a teacher at high school or college level that can do that. Like, no one knows why it doesn't work. It's supposed to, it doesn't. Maybe it's because we type it as y equals, so then y would always be my dependent variable and I need an input with it. I don't know. I'm not a programmer, okay? Now, that's how we do it by table. Right next to that, Do you remember how to do these manually?
Yeah.
How do I find, okay, you know, even better, I got this right here. How do I find my vertex?
Just put in 0.
No, it's second trace.
Okay, calculate occurs in two places in the calculator. One is up here with my graph stuff that says calculate a thing on the screen. The other is inside my stat menu. That calculates from your tables. I'm going to second calculate, and it tells me all the things I can find. I can find at a particular value. That would be like asking x, find out y.
Oh, minimum.
I can find a 0. I can find a minimum, maximum, intersection. These are when you head up to Calc 1 and 2. Okay, so in this case, since I have a minimum value, now remember, you can physically move Blinky around like this. Blinky, he's blinking at you. Look. Okay.
And then you got guess. No, she taught us that.
Now I can physically move it around like this. Y'all know that you can just poke a button, right? Say 5, and it'll put Blinky over at 5. It's going to ask you for a guess. You're going to say, tell me the answer, because the guess doesn't matter. It is literally for guess and check. So I'm just going to hit enter again, and it tells me my vertex is down there at 2, -4. Occasionally, you're going to see stuff like this. Remember, when you put Blinky here and Blinky here, it's taking those two coordinates and it's putting them in an algorithm. Occasionally, it's going to have round off error. Does anyone have 1.999997? Something like that?
What?
Okay. So depending on where you put your Blinky, it's going to have a tiny bit of round off error sometimes. Okay? So that's how I find my vertex on the calculator. Do you remember how to find it?
Vertex.
There you go. F of x is ax squared plus bx plus c. In this case, I have y was 2x squared minus 8x plus 4. The other way that I can do this is my axis of symmetry is always at x equals -b over 2a. So please, if you're going to evaluate, if you are ever plugging a value into an expression, use parentheses. Parentheses keep us from screwing up signs and exponents. Hopefully you found that out, because along the way, over the years, how many times did you take -9 and square it versus -9 and square it and get two completely different answers? Order of operations, right? Please execute my deranged adolescent sister. This says take -1. I had kids make up their own years ago, and that was the one that stuck. -1 times 9, then square it, because it's in parentheses. Versus this, what comes first? -1 times 9 or 9 squared? 9 squared comes first. So it's going to take 9 and square it, and then tack a negative on there. Okay? Please use parentheses when you evaluate these. Go on my side quest about the ramp that division and subtraction are also a lie. What else we got? B.
So
-8.
when you do that formula, -b 2a, and then find that number and then plug it in your calculator, like the x thing.
I could ask x. I could trace to that number. Yes.
That is easy now.
Okay.
Or you can plug it back in.
Or you plug it back in here too, and that's where we're going with this. If I have -8, it's 8. 2 by 2 is 4. 8 over 4 is dose. I just found out I have an axis of symmetry at 2. If I have an axis of symmetry at 2, that means it goes right through what? What point on a parabola does that go through? It goes through the vertex. If it goes through the vertex, then that means it's a coordinate. A coordinate has an x and a y, and you all know that if you have an x, you better find out y. So I'm going to plug in the function of that is 2 by thing squared minus 8 by thing plus 4. I'm going to plug in 2. Getting 2 squared is 4, by 2 is 8. 8 by 2 is 16, 8 minus 16 is negative 8, negative 8 plus 4 is negative 4. So if you would please, next to this, if you don't remember it, the official way to write this is that my vertex is always at negative b over 2a, function of negative b over 2a. Remember, function of means f is the name of the function, thing in parentheses is what I'm plugging in. This is saying, somewhere along the way you've had a teacher tell you, and this is incorrect, f of x is just a fancy y. No. Okay? F of x is the name of the function and its input. Then I give you the expression, that's the rule, that's the coding behind the machine, and then it gives me a y as an output. Now we all know you can cut out the middleman, right? It's Thursday. I have someone in my quote book for that. Hey Kevin, it's Throat Punch Thursday.
That's good.
Okay? So if it's Thursday, it's Throat Punch Thursday. If it's Throat Punch Thursday, Kevin gets punched. Today is Thursday. What's happening? Kevin getting punched. You can cut out the middleman, right? So that's why some teachers will say f of x is just a fancy y, is because they are talking about the same object, but they're talking about it in different contexts. Okay, what is this?
Thumb up.
Right? Is it a thumb? Is it a opposable digit? Is it a phalange? Is it a button smasher? No, this is my reload. Okay? Fire, reload. Fire, reload. Okay? It depends what context I'm talking about it, right? Like if during this class, you're probably going to see one or more of my seniors passed out on the couch, and I'm going to, like, I could, yeah, yeah, they're over here. I could say to any one of my students, I could be like, what's up, Nora? I'm talking about person by name. Or, what's up, nerd? Okay, now you're one of mine. It's still the same person, but I'm talking about them in different contexts. You have to understand this. Yes, this gets you y, but this is saying I will plug this value into the function rule, and it will give me y. It's a little bit of a difference. Some might argue it's semantics, but boy does it matter when we head towards inverses and compositions. Really matters. So, we found a vertex at 2, negative 4. Womp. Do you remember perfect square steps? Because it's a parabola with x squared, it's going to move in a fashion that is unit squared.
Like 1, 1.
Normally, from the vertex, I go over 1, up 1, over 2, up 4, over 3, up 9. It moves in square steps. But this guy has a vertical stretch. So if you need to write this, remember my vertex is here. I'm going to go over n, and I'm always going to move up or down a times n squared. Those are my perfect square steps. So if I move from that vertex over 1, I'll go up 1 times 2. Over 1 up, not 1, 2. From here, I'll go over 2 up, not 4, 8. From here, I'll go over 3 up, not 9, 18. That's how I get my points. I don't just BS them. I don't just look at my table every single time. I use perfect square steps because it's a squared function. I hope this sounds familiar, because you should have been doing this for 2 classes at a minimum. If it's on the right one, I go left one. If it's on the right 2, I go left 2. If it's on the right 3, I go left 3. I connect the dots. I try to keep it curvy. Okay?
Yeah, that was good.
Speak up. I went over 1. I went up 1 squared times 2.
That's what I ended up figuring out on the final.
I went over 2, up 2 squared times 2, because it's twice as tall. I go over 3, up 9 times 2. Over 4, up 16 times 2. I'm always moving in square steps. Yeah, it is.
We had like a table, and then we had to do a thing, and on the final, I taught myself that. So.
No, dude, this is what we did back in Algebra 1.
Well, that's what we did in Algebra 2.
Okay. So, you already have this graph on here. I'm going to show you this again with, flip the page. Oh. Ta-da. Let's do it again. Okay, 1, 2, negative 3. Negatory. We're going to do this manually to make sure that we understand those perfect square steps. We have f of x is x squared plus 2x minus 3. Step 1, axis symmetry. Now, okay, I'm doing this because this is part of our review and these are skills that we should know. And as I reference them throughout the class, if you don't know them, you're screwed. That's why I'm making us do this now. Now, after we pass this, I don't care how you graph it. You do you, okay? Same as on ACT. First up, axis symmetry. We're going to graph it on the left-hand side. That x is negative b over 2a. What is b and a?
2 and 1.
2 and 1 respectively makes negative 1. Then I say the function of whatever that was is thing squared plus 2 thing minus 3. I'm going to plug in negative 1. Negative 1 squared is 1. 2 by negative 1 is negative 2. 1 minus 2 minus 3 is negative 4. I have a vertex at negative 1, negative 4. So, dot 1, negative 4. And I will label it as such. Is this a maximum or a minimum?
Minimum.
How do I know?
Because the vertex, it goes up. It's positive. Yeah.
The positive or negative on the a coefficient. Yes?
Isn't it negative 1 instead of positive 1?
What?
For the
Yeah,
vertex.
it's negative 1 instead of positive,
X.
and then it's a plus.
Oh, I went to positive 1. Oops.
Is that a brownie point?
Uh-huh.
Yeah.
First blood. Wait, didn't y'all get one yesterday? There was a bunch of nerds over here, so I know that I forgot to write 2 of them for PreCalc. And then
No, he's the only teacher.
And then
Teaches pre-calc.
for this year.
There's usually one.
No, next year I'm not here, so someone's going to pick it up. What's fair for 10 kids? 10 versus 1.
Yeah.
11.
10 seems excessive.
5.
No, I mean excessive like that's too low. The other class is at 20.
13. Wait, they're at 20.
They have to get, at 20 brownie points, you get food.
How much?
Y'all.
How many kids are in there?
18?
Oh, so then
Yeah.
do
12.
so like 12. Yeah.
Okay.
13. Hey, chill out.
All right. I'll probably regret it, but I'm going to go for it. Okay.
Also after lunch too.
That completely depends on whether the ADHD meds are still working and whether I caffeinated at lunch or not.
Okay.
So, and heavily depends on whether Baby Bear let me sleep. Now that I have my vertex, perfect square steps. From the vertex, over 1, up 1. I don't change that because my A value is 1. No stretch or compression. So from there, I'm going to go over 1, up 1. Now, don't go from this point. Not from this point, always from vertex. Over 2, up 4. From the vertex, over 3, up 9. Over, well, it's also the number of times that you do it, the number of times you see it. Okay? Practice makes fluency. Over 4, up 16, which is somewhere off-road.
Wait, shouldn't that be only up 4 on that third point? Isn't that up 1?
No, over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then remember that you have this axis of symmetry right here. So if I went 1 to the right, 1 to the left, 2 to the right, 2 to the left, 3 to the right, 3 to the left, 4 to the right, 4 to the left. It's just fun to say it in that tone because you throw it on auto tune, you'll make millions, right? So try to put it with a parabola that is, again, keep it curvy. Hey, that one wasn't too bad.
That's why I'm always
So,
thinking 8 is cube.
now, we also have cube steps to make cubics and cube roots. We also have fourths to make, like, and it just keeps going from there. All right.
I'm just glad I'm on it.
Womp, womp. So what I would like you to do is over here, I'm going to make up a thing. And it's probably not going to be the same as first hour. Let's do negative x squared minus plus 5x plus 1. There we go. Find your vertex. Plot your points. I'm telling you right now, your vertex is going to be at something with fractions. You're a big kid. That sounds like me in running. I can run for a short distance. When I coached football, I scared the crap out of some kid by chasing him down from behind. About had a heart attack afterwards, but it was worth it.
Oh, that's a negative.
Oh.
Yes, it's
No, I didn't see the negative in front of me.
Chase. At least I understand. Can we use a calculator or manually create?
Oh yeah, use a calculator to do the arithmetic. I don't care. I would like you to be able to do this by perfect square steps just to practice that.
What do you click?
Alpha y equals.
Oh yeah.
Do you see why chapter 0 is called Do You Even Algebra 1? Do I want 60 or 186?
That's so. Plus.
-7.
You ballpark it,
-7.
right? If it's at like 2.5, I can ballpark 2.5.
2.5.
So it should be
And 3 points, negative 3.5. And it's flipped.
so 29 What number is that?
5 halves, 25 fourths, negative 25 fourths, 25 fourths, 50 fourths. It's going to be 25 fourths, 25 fourths is 29 fourths. Good job. Is 5 halves, 29 fourths is going to be 1, 2, 3, 4, 5, 6, 7, and some change. Or 1, 2, 3, 1, 2, 3, 4, 5.
It's a
1, 2,
negative
3.
thing, so it has to be flipped.
No, isn't it negative? That's
No, it's a
It's 5
positive 5 halves. And
That's-
then you
yeah.
plug it into this thing with the X.
no, that's wrong.
No, you're wrong.
You add.
I am wrong, because that's not what I have.
Yeah. See, I'm right. Match that? Yep.
So what I do wrong?
I don't know. What did you do wrong?
So I plugged in 5 halves equal. Oh, that was stupid. I didn't switch the equation.
It happens, dude. By the way, don't call yourself stupid or I'm going to hit you with the dinosaur.
X.
It's my student you're talking about. Be nice. I'm going to leave this handy.
It's 29 fourths.
Yes, it is.
I just go That's fine.
Oh.
This is great. Beautiful.
I kept mine as common denominators. Okay, start with negative b over 2a. Watch your signs. You should have 5 halves for your axis symmetry. Or x equals 5 halves. Remember, axis symmetry is a line. Lines have equations. You need x equals. Plug in 5 halves. Watch your signs and your parentheses. A 5 halves squared is 25 fourths with a negative in front. 5 by 5 halves is 25 halves. I'm going to call it 50 fourths so that I'm in common denominators. Instead of adding 1, I'm going to add 4 fourths so I'm in common denominators. Or I'm going to dump that whole honkin' works into my calculator and hit enter.
I just put that in my calculator.
Yeah.
The orange and green stuff, yeah, you can.
What?
Those are a right view calculator. A right view calculator, you can type it exactly the way you wrote it.
Let me break it down. So you put in the thing right here, and then you go over second graph.
First hour got through the next 3
You gotta make sure
problems.
you get that to that, and then click second graph.
We had a little
And then you gotta click
We-
at
alpha.
the beginning of class though.
Alpha y equals
Okay.
enter, then after you do the negative b divided by 2a.
Is everyone getting there?
Get that, negative
Okay.
y.
Maybe just little hiccups and goofs, miss a negative here, parenthesis there. Accidentally say, I don't know, 2 squared is 8 or something like that. Yes, ma'am?
So now this goes down, right?
Correct, because there's a negative out front in the A spot.
So then to do.
So here's the deal with these perfect square steps. If this is at this right here is at 5 halves, 29 fourths, may also be called 2.5, 7.25, because it's a terminating decimal, and I'm okay with that. From there, I can still go over 1 and down 1. I can still go over 2 and down 4. It's just going to be in that same goofy spot every time I do it. Nothing wrong with that. I just ballpark it. About halfway through the box, about a quarter of the way through the box. Okay, and then I connect the dots. This one, I made that point because my y-intercept is 1.
Wow, that's
So I'm also able to mirror it onto the other side. Okay.
And it was lucky enough to be straight on X as well.
So, the other thing we need to talk about before we get some more practice, we did the first 2 on the next page in the other class just for extra practice, and we're also going to start with those tomorrow. But I definitely need to talk about this. Do you remember what domain and range are?
domains, y values, ranges.
No, you just got that.
Okay. Domain is who's allowed into the party, and has very specific rules. In fact, right now you should only know 3 of them. Okay, we called them in our classes, we called them the commandments of domain. Mathocles comes down from the hill with his tablet of math, and he says, "Thou shalt not." The first commandment of domain is, "Thou shalt not divide by 0." Right? I can't take a number and divide it by 0. This would be like Grug from the Croods. And they died. Because you can't do that. Like, divide something into 0 pieces. I dare you. Go ahead, cut that into 0 pieces.
Can't.
You always get the one kid who's like, look, I did it, right? That isn't division. I didn't cut it. I subtracted. Okay, those are 2 very different things. We also learned back in Algebra 1, thou shalt not take even root of negative numbers. Okay, I can't take a square root of a -9. I can't take the square root of a -5. Not possible. That's why my answers are all imaginary. I can use I and I can work with it. That's what unlocks the rest of mathematics, but I can't just do that. I can pretend I did. 3, you should have learned towards the end of Algebra 2, log base b of any non-positive. You cannot take the log of a non-positive number because logs have a vertical asymptote at 0. Nothing exists before that. It curls along that asymptote and then takes off. Okay? Chapter 3, we're going to do it again. Number 4, to be continued. We'll hit that in chapters 4 and 5. It has to do with inverse trig functions. Okay? So when we talk about where the maximum or minimum value of a thing is, will this have a maximum or minimum? How do I know? Because?
If it's to the second.
It flips it, so it's like.
I have a -3. That means it's a sad parabola. If it's a sad parabola, it has a maximum. So I'll have a maximum value up here at -b over 2a is -12 over -6 is 2. Plug 2 in. 2 to 523. So I'll have a maximum value at 223. You have to be careful how you write it. I mathed. -b over 2a, plug it in.
Oh, that's vertex. Yeah, never mind.
But where do you get the 23s?
I plugged it in.
Oh, that's impressive. Not
Okay. Y'all, I'm autistic. I don't people with neurotypicals, but I can math. All right. This is my jam. This is my hyperfixation. I've been doing this forever. I've been tutoring since I was 12. Okay. I can do that fast. If I can't, I shouldn't be teaching. Maximum or minimum value. We said it has a maximum. The way that we write it is we say it has a max of 23 at x equals 2. The 23 itself is the maximum value because that's the highest it ever goes. But it happens when x is 2. So it's kind of like saying, what's the best pop in that machine? Oh, easily mellow yellow. It happens when I push this button. Okay. State the domain and range of the function. The domain. This is why I wrote that up there. Do I have anything in my equation that's going to break one of these commandments? Do I have x on denominator?
Negative.
Do I have a right? Do I have an even radical? Do I have a logarithm? Since none of those things are in my equation, then the domain is going to be all real numbers. Or you may have seen negative infinity to infinity. We're going to hit interval notation and set builder notation again at the beginning of chapter 1. The range.
That's what it means.
What's the lowest that the function ever goes?
Negative.
What's the highest it ever goes? So if you don't know interval and set builder notation right now, because you took Algebra 2 more than 1 year ago, that's okay. You can just say y is less than or equal to 23 for now. But if you remember that it's all y's such that y is less than or equal to 23, where y is an element of the reals, or negative infinity to 23, can't touch this, can touch that, then, okay, you can write one of those.
Why does the negative come first?
Because it goes lower. And that's a graph.
That's how a number line works, from the smallest to the largest.
That should be
I
a
think
graph.
we wrote it different in this works. It was like just like a negative infinity.
And then when it includes it, you write the graph.
But were you in there second semester last year?
No, I
Last
was in it
semester.
last semester.
Okay. Well, that crew, like half of the class cheated their way through quadratics and polynomials.
Yeah. She taught
And
me
that's-
We were in geometry. And she taught.
And we had to specifically say, y'all don't come up to PreCalc, you're going to get hurt. Because they just did not have the prerequisite skills because they didn't learn it, they cheated it. Flip it over, next page. I know the bell is about to go ding. We went through numbers 18 and 20 for extra practice during first hour. That's it. I would like you to do those two. I'm going to have an assignment. The assignment will be in the book. It will not be in chapter 0 because chapter 0 through 2 in this book does not match with the 0 through 2 in the notes that I'm using because they're my old notes, okay? Just roll with it. I'm going to say like page 180 something, do these problems. You're good.
Can we
Okay.
see the answers to this, like somewhere? Because like we did these, but we never actually finished them.
Oh,
Right?
look in the video. I finished them with the other class. Okay. No, it's just a couple of minutes difference. Also, I'm super dysregulated in the afternoon. Y'all can't let me go on a tangent too far. Reel me back in. Okay? And don't try to get me off course. I have a feeling at the front table. I got a feeling. This is where we say sus.